Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Finishing out topic 6, where we can find the whole if we know the part and the percent. You know the percent that you're taking, you know what that would equal if you took the percent times the whole, but we just don't know what we started with. And so we're going to be able to find that after today. So two strategies that we're going to look at. One, using the equation. I'll show you that in a moment. The first, though, is to use a double number line, again, a visual representation. And so the problem we're looking at here is 90% of what number, right? So 90% of, right, multiplication, a number that we don't know, is 135. And so we set up our double number line. You'll notice on the percent line, right, that it is broken up into 10 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, where 90% is at, and then 10 being 100%. And then on the second number line, you'll notice again, still broken into 10 sections, except 135 is where the 90% lies. Right? So if all we're focused on is that, you can kind of use that information and a little bit of reasoning to do some division, okay? And so you figure out, well, if 9 sections is 135, I wonder what just one section would be worth. And so to get this answer of 15, right, that's kind of the math that you would do. And then to figure out how much 10 sections, how much 100% would be worth, you just add on the 15 to 150. If you are having questions about using a double number line, please come and see me. Again, I want you to be aware of it. I want you to be able to read it and understand it. Do I think you will draw them to solve problems? Probably not. Okay. The second strategy, though, very efficient and one that I think you will definitely use, is to use an equation. So again, 90% of multiplication, a number, in this case we're going to use P, is 135. So if P is the total, if P is this unknown, right, 90% of multiplication, the P, right, is 135. I go through some steps from 6-2 where I turn 90% into a decimal. And then I solve the equation by getting the variable alone by itself, all the way back to topic 4. Okay, and to do that, I use division, the inverse operation of multiplication. So really the problem that you're solving here is 135 divided by 90 hundredths, or 9/10, right? We get rid of the decimal on the outside. 90 goes into there once. That's 90. You're left with 45 zeros in our empty pockets. How many 90s are in 450? That's 5. That's 450. Bring down my last 0. That's 0. Notice that I got the same answer, 150, that I did when I used the double number line. This one, to me personally, makes a little bit more sense. Okay? So the whole idea here is you set up the equation, and then you solve to get the variable by itself. So a student took a math test and scored 152 points, which was 95% of the total possible. What was the total number of points possible? I do want to point out that the key to solving percent problems, whether it's 6.5 or 6.6, is knowing what the missing piece is. Here I'm missing the total. Okay? And so that's very different than when I was missing the part or the percent. Why don't you pause it and try? A lot of work just showed up on the screen. I want to point out a couple things. First, in red, you'll notice that I turned the percent into a decimal, section 6.2. Okay. Next, over here on the right, you'll notice my initial equation here that I'll bookend, right, where I took the percent, 95 hundredths, times the whole that I don't know is equal to 152. I got the variable alone by itself, P, down here, by dividing by 95 hundredths. Over on the left, you'll see my long division. Okay. And you should have gotten an answer of 166 possible points. So just some general ideas to remember here. Number one, a percent compares numbers to 100 and can be written as a fraction with a denominator of 100. So you'll notice here 100%. I have some technological difficulties today. 100%. Let's try writing that again. 100% is equal to 100 over 100. You can use the fraction bar or the slash. And anytime you have a numerator and denominator that are the same, that's one whole. You can also write any percent as a decimal by dividing that percentage by 100. For example here, right, I have 43.5%. And if I divide just that by 100, that's my decimal point moving to the left. I end up with the percent as a decimal. Going the other direction, let's say that I have this decimal and I want to convert it to a percent. I would multiply by 100 and my decimal would shift to the right twice and you would end up with a percent. Okay, so just some helpful reminders. Okay. So we're going to need to do a little bit of highlighting and a little bit of fixing on this particular page. First, let's highlight that this is how we're going to find the whole if the percent is bigger than 100 or if the percent is a decimal. And then the second thing I want to point out is that this question that I'm going to underline is technically different than the one written in your notes. I made a typo in the notes and I fixed it after I printed and made copies. So please fix the underlined question that's there. So what happens when the percent is greater than 100? Well, you still set it up the same way. It's just as a matter of recognizing what that percent would be as a whole number or as a decimal. So 200% of what number is 40? So here's my equation. Right? Notice 200% of some number equals 40. Right? And the key here is we're going to write 200% as a whole number. So let me remind you of something. 200%. Percents are always the number compared to 100. And then you could simplify that fraction, and that's how I got the 2 here in my equation. So 2 times something is 40. Well, I want to get the variable by itself, so I'm going to divide by 2. N is equal to 20. If you have questions about that, again, please, please, please stop me. What happens if the percent is a decimal? Well, I have 62 5/10%, and I need to turn this percent into a decimal. How did I get from this equation to that equation, you might ask, right? Well, I took 62.5% and I divided it by 100. Just like I showed you in the previous slide, right? So when you divide by 100, the decimal hops to the left. Our place values get smaller by 2. By 2 place values. And so 62.5% of some number is 30, would end up being 625 thousandths n is equal to 30. And then to solve this, we're just going to divide by 625 thousandths. You get n by itself. Right. Get rid of a decimal. So I have none, I have none, I have none. I have 4. That would be 2,500. And then how many are in 5,000? That's a great question. It's going to be less than 10 because that'd be 6,250. Let's try 8. 0, 40, 16, 20, 48, 50. Boom! Nailed it. Doesn't it feel really good to guess and check and get it on the first try? If you have questions about anything that's going on the screen, please stop and see me. Otherwise, I want you to try these next two using the strategies we just saw. So pause the screen and try it. All right. In the top problem, I turned 300% into the whole number 3. I wrote that as a fraction where I compared 300 to 100, simplified to get 3. 3 times some number is 180. That would be 60. In the second problem, I turned 0.3% into 0.03. That's what's going on right here, circled in black. Okay, and then I solved the equation 3,000ths times n is equal to 24, and that got me 8,000. Long video today, I know, but it's the last one of topic 6. Finish out 6.6. Practice buddy. See me with questions. Otherwise, have a great day.